All right, guys. So if you're watching this, you are confused. You need help. I'm here to help. Your particular confusion comes to the concept known as the law of conservation of matter. And I'm going to spend the next 3 to 5 minutes helping you out with that. So let's start with the law of conservation of matter. And yes, it's very exciting. So we're going to add like 1,000 exclamation points. Woo! All right. So the law of conservation of matter, exclamation point times whatever, it states essentially that matter cannot be created or destroyed. Okay, that's all fine and dandy, but why is that relevant to the work we've been doing in class? Well, the reason that that's relevant to the work we've been doing in class is that it means that the number and type of atoms in the reactants and products of a chemical reaction must remain the same. In a chemical reaction, the bonds of the molecules break and the atoms rearrange to form new molecules. Okay? They don't necessarily always break. Sometimes they come together. Two atoms will come together to form something new, but you get the point. So if matter cannot be created or destroyed, and the number and type of atoms in the reactants and products of a chemical reaction must remain the same, and in a chemical reaction the bonds of the molecules break and the atoms rearrange to form new molecules, you still might be wondering, well, what's the connection between the number and types of atoms and the fact that matter cannot be created or destroyed? Well, here it is, and this is key. I'm going to bold it. Matter is made up of atoms. Yes, indeed. And if matter is made up of atoms and matter can't be created or destroyed, then we can't destroy atoms in a chemical reaction. They have to go somewhere. They have to be accounted for. And so we've been practicing with different kinds of atoms, and sometimes we use real atoms like hydrogen and oxygen, etc. But for this tutorial, I'm going to keep it really simple, and we're going to use the colors red, blue, and green. So do we know when a chemical reaction obeys the law of conservation of matter? Well, in order to know, we have to first know a couple of things about a chemical equation, or one that's laid out, such as this. And the first is that everything to the left of this arrow right here is the reactants. It's what's reacting. In other words, what are the two things going through a chemical reaction, or the three or the four things going through a chemical reaction? In this case, there are two different substances going through a chemical reaction. How do I know? There's a plus sign, there's molecule here and molecule here. Okay. Now remember, when a chemical reaction happens, there's millions of molecules going through this reaction, but we're trying to break it down to its most basic form. So here it is. In other words, if we mixed just one molecule that was made up of a red and a green with a molecule of two greens combined with a blue, then we would get on the other side a molecule of green and blue, red and green, and green. So that leads us to the right side of the equation, which is the products. It's what forms after the reaction. So when these two molecules react, we get these molecules on the other side. So how do we know if it obeyed the law of conservation of matter? Well, we can't have destroyed matter, which means we can't have destroyed atoms. And the way to figure out if the equation obeys the law of conservation of matter is to count up the atoms in the reactants and compare them to the atoms in the products. So let's do that. I've made the reactant count down here and the product count down here. I highly suggest you do that when you have an assessment, assessments that are coming soon, just to let you know. The left side of the equation has, count them, 1 red, that's right there, 1. It has 1, 2, 3 greens, 3. And it has 1 blue. Okay. Okay, so that's our reactants. Now the next question is, did they break apart and rearrange? Well, let's look on the other side. Yep, looks different. And that means that they broke apart and rearranged. What if they were the same on the other side? Well, if they're the same on the other side, then that essentially means that nothing really happened. There was no chemical reaction. So they have to rearrange, and that's a very key point. So let's count up our products, everything to the right of the arrow. To the right of the arrow, we have 1 red, we have 3 greens, and we have 1 blue. I don't know about you, but at WCMS, we all know that 1 red equals 1 red, 3 greens equals 3 greens, and 1 blue equals 1 blue. That means that in the reactants, we had 1 red, 3 greens, and a blue, and in the products, we had 1 red, 3 greens, and a blue. There you go. It obeys the law of conservation of matter. Why? Because there is the same number and type of atoms in the reactants and products. And since atoms make up matter, matter was not created or destroyed. It obeys the law of conservation of matter. Bye-bye.